Good morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today, in this session, I want to discuss about endurance limit. So in previous sessions, already we have studied about fatigue loading and endurance limit and stress strain curve. In this session, what are the affecting factors on endurance limit? So how to solve this type of the problems, we will see. The topic is endurance limit. So what is the effect of loading on the endurance limit? So that is called as load factor. The endurance limit of a material as determined by the rotating beam method is for reversal bending load. So, as for definition of the fatigue, whenever the component is subjected to repeated loads or cyclic loads, the component fail after certain intervals. So that at which the component fail, so that is the stress is below the yield stress. So there are many machine members that are subjected to loads other than reversal bending loads. So endurance limit means what is the maximum value of a repeated loads or the maximum amplitude of completely reversed stress value. So that is called as endurance limit. We can represent with sigma E. On this endurance limit, what are the loads affecting? So how to take the load factors while solving the problems? We will see. So thus the endurance limit will also be different for different type of loading. The endurance limit depending upon the type of loads and the type of material and the geometry of the component also affecting on endurance limit. So let take KB is the load correction factor for the reversed or bending loads. So it is value always take unit value. So that is 1. Ka is load correction factor for axial loads. So suppose the component is subjected to axial loads, need to take axial load correction factor while solving the problems. So while solving the problems and the value is taken as 0.8. Ks is the load correction factor for the reversal bending loads, shear loads. So whenever the component is subjected to shear loads, its value is 0.55 for ductile materials and 0.8 for brittle materials. So endurance limit for reversal bending loads. So write down the equation like this. Sigma EB is equal to sigma E multiplied with sigma B. So this value is the final endurance limit value whenever it is subjected to bending load. So as per theory calculated in sigma E, endurance limit multiply with KB. And similarly endurance limit for reversed axial loads multiply with Ka with actual sigma E value, theoretical sigma E value. You will get the actual endurance limit. Similarly, endurance limit for reversed the torsion loads or shear loads, sigma E multiply with Ks. Next one, effect of surface finish on a low endurance limit. So that is called as surface finish factor. One is load factors. Different loads are there, axial load factor, bending load factor and shear load factor. So how to take the factors and how to calculate endurance limit already we have seen in a previous slide. In this slide, shown the surface finish factor on the endurance limit. What is the effect of surface finish factor? When a machine member is subjected to variable loads, so that is fluctuating loads, the endurance limit of the material for that member depends upon the surface conditions. When the surface finish factor is known, then the endurance limit for the material of the machine member may be obtained by multiplying the endurance limit and the surface finish factor. So that is here sigma E dash final one is sigma E multiply with surface finish factor. You can multiply with K surface. So we will get that machine endurance limit for a particular material. We see that for a mirror polished material, the surface finish factor is unity. Next, surface finish factor, let case SUR, surface finish factor, then endurance limit is sigma EB multiply with sigma surface. So here, see the sigma EB, so endurance limit due to bending. So how to calculate this sigma EB? So already we have seen in the first slide, sigma E multiply with KB, bending load factor. So always take this KB value is 1. So now substitute sigma E into KB into K surface. Surface finish factor also here acting. So the final one you will get sigma E multiply with K sir. Similarly for reversal bending loads and reversal bending load is completed, and for reversal axial loads and torsional shear loads. So here sigma E sigma E multiply Ks multiply with K surface. Surface finish factor also the load factor also acting. Next one is effect of size and endurance limit, size factor. So we can represent the size factor is K size. So if the size of the standard specimen is increased, then the endurance limit of the material will decrease. The dimensions, the overall dimensions of the components is increased. So at that time, the endurance limit also will decrease, not increase, it decrease. This is due to the fact that a longer specimen will have more defects than a smaller one. If you have increased the dimensions of a shaft or any other the component, what will happen? So the size will be increased. So due to this size, some stress distribution carrying forces are very, so they're not carrying that much of force. So and also not maintaining a uniform distribution of stress. So already we have discussed in stress concentration. So that the specimen will have more defects. So at that time, you need to take some size factors. The effect of size of endurance limit, size factor, K size. Then you calculate again endurance limit considering size factor when it is subjected to reversed bending load, reversed axial loads, and reversed torsional or shear loads. Clear? So whenever you are considering the size, sigma E2 is equal to sigma EB, K surf and K size. What is sigma EB? EB is sigma E multiply with KB multiply with K surface and K here, bending load, load correction factor, and surface finish factor and size factor. We are considering all these three factors. So that's why multiply with these factors with sigma E, endurance limit. We will get final one. So similarly, for shear loads also. Remaining some miscellaneous factors also there in addition to the surface finish factor and size factor and load factors. So there are many other factors such as reliability factor, temperature factor, and impact factor, etc. Okay, it has effect on the endurance limit of a material. Sometimes if you don't know the factor value, the temperature factor value or impact factor value, you can take the unit value. Okay, effect of miscellaneous factors on endurance limit for the reversed bending load, the endurance limit. So here reversed bending load that so next is miscellaneous factor sigma E3. You can say like this. That is equal to sigma EB bending loads and here K surface and K size factor multiply with K load factor multiply with Other factors, so temperature factors and impact factors. You don't know those values, the impact factors. So whatever affecting on the factors, you need to multiply. So similarly for reversed torsional loads, the reversed torsional loads, same here, shear stress sigma e k surf multiply with k size, kb and kt and ki. For reversed axial loads also same, reversed axial loads, the bending sigma ea plus k surf multiply with k size multiply with k axial load correction factor and kt and ki. So like this you need to calculate. So what is the relation between the endurance limit and ultimate tensile stress? So it is for steel material, the endurance limit is equal to half of ultimate tensile stress. So for the cast rail, zero point 0.4 sigma u and cast iron 0.35 sigma u. For non-ferrous metals and alloys, so you can take in as 0.3 sigma u. So these relations are useful while solving problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.